And welcome back. Now today I'm going to do a totally different sort of video because I have, as you probably know, a 3D printer, and I've had it for about 3 months or thereabouts. And before I got the 3D printer, I knew zilcho about 3D printing. Yes, I'd seen videos on 3D printers producing these wonderful castles and dinosaurs and boxes for enclosures and stuff, and it all seemed like a good idea. And I thought, yes, I'd like some of that, please, but I haven't got the faintest idea where to start. And it took me, well, weeks and months to figure out what it was that 3D printing was all about. And that's what I'm going to tell you today before this sort of beginner knowledge fades away and it becomes, well, it's blindingly obvious, isn't it, how it all works? Because as a beginner, it most certainly is not blindingly obvious. So I'm going to give you some of the information that I still retain at the moment before it disappears, so that it might help you in your quest as a maker in deciding on how you're going to get into 3D printing, and indeed even if you want to. I want to have a big shout out for PCB Way, PCB Prototype the Easy Way. Now we all know about their PCBs, excellent that they are, but they also do, as you can see here, 3D printing, look. And it's 10% off at the moment, that's April 2023. Let's have a look what they do. Now as you see here, this looks quite similar to the PCB upload screen. You just upload your file, probably an STL or something like that, tell them what you want it to be made of, and it gives you such a wide choice here that you probably can't do on your own 3D printer. So I'm very tempted to try something like nylon or something, yeah. And you just upload it, tell them what you want, the colour and so forth, and that's it. You submit it, get a request for a quote, and Bob's your uncle. And yeah, that's going to be my next step, I think. And don't forget, they also do flex and rigid flex PCBs. Now these are really something quite special. If you need that sort of thing, you really need to look into it. It's great. For us hobbyists, standard boards over here, $5 for 10 pieces. How can you go wrong with that? I suggest we check them out right now. Now, before we think about 3D printers, the actual physical printing unit, we should take a couple of steps back and go, let's forget about that. We're not going to look at the actual physical machine that does the printing in the same way that you don't look at a car in a showroom before you can actually drive a car. Yeah, so before you've got your license and you've any idea of how a car operates and how you can steer it in a straight line without crashing into things whilst you're changing gear and indicating the mirror signal maneuver and all that kind of stuff, you've got to get to a certain level, haven't you, before you can do anything in a car. And the same applies, in my humble opinion, with a 3D printer. Now, admittedly, you could say, I don't want anything to do with the design of 3D prints. I just want to take ready-made models from Thingiverse or printables and say, oh, I'll have one of those please, and I'll have one of those and one of those, and that's great, that's all I want. Because I want to, I don't know, print some toys for my grandkids, or print a box, and that's about the right size and everything. And there are literally thousands and thousands of prints out there that people have shared for you to download. And if you don't modify them, that's fine, and if you do, that's fine too. Of course, if you want to modify them, you'll need to know a little bit about CAD design. Now, CAD, computer aided design, is not only used for 3D printing, it's used for all sorts of things, isn't it? Whether you're going to use injection molding or even metal work. But let's keep this focused on makers like you, Arduinites, people are using, Raspberry Pis, ESP32s, and they're making projects and they want 3D prints for that. Slight warning here, you will find that as soon as you get into 3D printing and you think, yes, I want to make one of these for my project or one of those, before you know it, you're making something else that's got nothing to do with Arduinos or anything else. Yeah, that's just one of the risks you're going to have to take, I'm afraid. Okay, let's step back then and say, how do I design something that I can then subsequently print? And unfortunately, there's no shortcuts to this. There are levels of difficulty that you can go through depending on what your needs are. But I'm not here to promote one program over another. It's probably best that you download 2 or 3 of them, see how they look and whether they gel with the way you think and work, as I did, and one may be totally alien to you, while another might be going, oh yeah, I can understand that, I can get on with that. That's what happened to me. So you'll hear words like Fusion 360, which is probably the most complicated 3D CAD program in the whole world. You could design a jumbo jet with it, I'm sure, and very capable it is too. And for the most part you have to pay for it, but for makers, or at least hobbyists, you don't have to pay. You can get a hobbyist sort of license and you can do what you want with it. It's great. However, it is a very, very steep learning curve. At the other end of the spectrum, there's something called Tinkercad. Now, Tinkercad is something that kids use, or at least can use. Yeah, it's simple enough for children to understand, and they can make little designs with it, boxes, whatever. However, there are some downsides to using something like Tinkercad, unless your needs are very simple, because if you go back and try to amend that design, it's not what they call a parametric design tool, which means you haven't got any parameters. You haven't said this is 10 centimeters by 3 centimeters. You've just given it a size initially, it's done it, and that's it. It's forgotten all about it at that point. Now, I'm sure there's lots of people out there using Tinkercad quite happily. And they're going, well, I don't understand what you're saying, Ralph. It's fine for my needs. And I think that's great. If Tinkercad is what you need for you, carry on using it. And indeed, I strongly recommend that all beginners at least download Tinkercad because it's free, try it out and think, do you know what? I could do something with that. And some designers use Tinkercad for those simple little things that are just easy to produce, and it's too much trouble to fire things up in others. I personally use something called FreeCAD, which drove me up the wall initially, even though I could sort of grasp what it was trying to do, but it was much more like a technical drawing program to me. I thought, I don't understand this, but then I discovered a couple of channels on YouTube who painstakingly go through each aspect of it, and you do have to put in the groundwork. And I suddenly thought, I understand what you're telling me. Unfortunately, that meant now I could see the almost vertical wall I'm going to have to climb first to get over the foothills, if you like, to produce something meaningful. But with a bit of application and effort, it's all very doable. As it would be, no doubt, with Fusion 360, but that's like yet another level of complexity that you have to learn. The best thing to do is to download 2 or 3 of these programs at various levels of difficulty. So Tinkercad at one end, Fusion 360 at the other, FreeCAD somewhere in the middle really, I suppose, and decide which one's for you. The other thing is that I'm aiming this advice, if you like, at makers, which means you're probably making engineering type things, you know, boxes or brackets or even stuff like this. Look, this is one of the very, very first things I made. It's a 2-part design, and it's actually a vent where this goes through the underside of a lid. This one here with some holes in it goes over the top, and it works very well. And I'm delighted to say it's the first thing I printed, and it worked marvellously well. And it's out there in my garden at this very minute. There we are. There's a nice little picture of it. But what I'm not producing is dinosaurs or toys or things like that, or indeed art, modelling type things where you have strangely shaped vases or just designs generally, because that is not the sort of thing I want to produce using either FreeCAD or Fusion 360 or even Tinkercad. They're just not really designed for that. You might have to think about other programs that lend themselves to that. For example, Blender. Blender can do both technical and artistic type designs, but it's another learning curve that you might think is one too many. So what I've told you so far is that there are umpteen CAD programs out there, all aimed slightly differently, lots of overlap of course. Yeah, you can probably make a box with any of them if you want an enclosure for your project, something I've yet to make, funnily enough. The one thing I thought I would be using CAD programs for a lot, I haven't actually done yet, but I'm sure the time will come. So out of all that big long list of CAD programs scrolling through there, you've got to say, how do I know which one I want? And the only way to know is to go to each of the websites for those, or read articles that say this is good, that's not so good, these are the strong points, these are the weak points of each one of these. And even Fusion 360, nobody's going to tell you it's easy. Yeah, it's hard. Whereas Tinkercad will say, yes, it's pretty easy to get to grips with that, and you'll produce something pretty quickly. But then you might outgrow that very quickly and then become frustrated because you can't do the more complex things or go back on your designs and just tweak them a little bit. So every program has got its ups and downs, and it's unfortunately legwork on your side that's got to decide which one's right for you. Now, in the same way as that when you're learning to drive a car, having never driven a car in your life before, can you remember that far back? Long time ago, wasn't it? But when you can't drive, you've seen other people do it, and you think, well, that's easy, I can do that, until you have to do it yourself, and then you discover just how difficult it is. And of course, we're not just talking about putting the car in motion, and let's think about a manual gear shift car, yeah, something that requires a bit more dexterity with your clutch pedal and things like that. Even if you manage to master that bit, whilst you're mastering that and changing gear, you're finding you're veering all over the road. Now, I taught my daughter to drive, and I can remember quite clearly it must have taken us a good couple of weeks before she felt comfortable in just starting the car off, changing gear without, as she took her hand off the steering wheel to change gear, turning the steering wheel and veering towards the curb, I should say. And all these things eventually become second nature. You don't find experienced drivers out there, you know, wandering over the road. Well, not too often anyway. So it's easy for experienced people to say, oh yeah, that's no problem, we can do that. Well, it's not so easy when you're a beginner. Okay, we've gone round the loop a little bit with CAD programs then, haven't we? And it's up to you really to decide which one you want and the level of complexity you're prepared to accept and the amount of work you're accepting in learning how to use it to a level that lets you become competent. Once again, in the same way that a learner driver has to learn various things in a car to become competent enough, okay, in a car not to crash or kill people, but in the 3D world you don't want to have a 3D design that doesn't hang together or is in some way flawed and can never be printed. So there's a certain amount of work and it shouldn't be underestimated. That said, everybody seems to manage it who wants to do it. So yeah, if you're not going to download stuff that other people have designed from Instructables or Imprintable or Thingiverse or whatever, then you are going to need to know those skills. And you don't have to know them all. I know that much, but I can still produce some meaningful products. I'll show you one at the end of the video, one I did just a couple of days ago, which surprised me that I could actually do it. But there we are. Okay. CAD program then goes round in the loop, and when you're designing a product, whether it's a box or a lid or indeed one of these vents that I made, the amount of time that you're spending doing it should be probably about 80% doing this. Yes, I know the printing can take hours, but it might not. If you happen to buy a very fast printer, it could print this in maybe 10 minutes, whereas my printer took an hour or more, I think it was, to print each part of these. But the actual time the printer takes is almost irrelevant. You can be doing other things in that time. So the time and effort put into the design really reaps rewards, because you're not spending 2 hours printing something that you suddenly discover does not fit together. It bangs into it and goes, oh, I didn't check the clearance on that. Luckily, I learnt that lesson before I printed it, so it did fit. Lucky for me, eh? Now, your CAD program, when it's finally done, you go, yeah, that's it, that's my design now. You export that design in something called STL format. The file is actually file name .stl. STL stands for Standard Triangle Language, or sometimes it's called Standard Tessellation Language. Tessellation as in polygons, triangles, whatever, octagonal thing, shapes basically, yeah, because the output of anything you produce is made up of minute, and we are talking minute, really tiny triangles or octagons or whatever. So that if you were trying to produce, say, a sphere, what actually happens in the STL file is that you get tiny, tiny, tiny little triangles created, and because they're so tiny, to us humans, it looks round and smooth and, well, ball-like, basically. But at the end of the day, your printer is actually printing tiny, tiny little triangles, or shapes anyway. It's almost irrelevant though, because the STL file gets sucked into your slicer. Let's talk about that then. Okay, step 2 then, slicer. Now the slicer program you use probably depends very much on what printer you end up with. Now you can still play with a slicer from any of the major manufacturers before you even buy a printer of any kind, just to see what it does. And I did that. I downloaded the Prusa slicer just to think, I've no idea what it is you're talking about. Let me have a go. So loaded up the slicer, and you can see the model imported, your STL file imported, and it shows you that in 3D, and there are various parameters then you can set, whether it's how much filament to produce on each layer, because that's how 3D printing works, layer by layer like a cake, but it's tiny, tiny, tiny layers. 0.2 millimeters is not uncommon. Your 3D print prints it in these slices, horizontal slices, and your slicer program generates the code, what's known as G code, geometric code, for the 3D printer to understand. Now, why is there not just one big universal slicer then that everybody uses? And the answer is the slicer you use, A, is probably made by your manufacturer, or at least has been adopted by your manufacturer, same way that Prusa took an open source slicer and then tweaked it for its own use and is now developing it sort of independently. And of course your printer might be able to have some capabilities that other printers don't, and so the manufacturer has changed the slicer to execute certain instructions that other slicers will go, I don't know what you mean by that. It's almost an irrelevancy though, because what you're actually doing at the end of the day is saying print with this sort of height slice, 0.2, 0.3, 0.4, whatever it is. I want you to do the infill between two walls. For example, if you have a box, you don't print the thing solid, even if it's only 2 millimeter wide walls. You don't print solid plastic. You print one wall and the other wall, and just have a little bit of filler in the middle. It's known as infill. And you don't need very much to make it very, very, very strong. 15% infill is more than enough. But your slicer's probably got all that as a default. If you never touched any of the settings in your slicer for your actual physical printer, it would probably work very well indeed. All that said then, the last remaining piece of the puzzle is the printer itself. So if you're doing all this stuff up front, what's so special about the printer? Why are all printers capable of doing everything? So 3D printers then, let's talk about that. Why aren't all 3D printers equal? Well, initially, years ago, 3D printers were a hobby unto themselves. If you bought a 3D printer, you had to be prepared to spend considerable time just getting the thing working and running and not falling over every 2 minutes, whether that was the actual software or the hardware. Imagine the cars of, say, the early 1900s. If you were rich enough to afford one, you still had to then keep that car somehow running, and you had to know the intricacies of that car very well. You need to know really how to take all the spark pluggy bits off and cylinders and pour fuel in and starting handles, and yeah, it was a hobby in itself. Ditto, 3D printing was a bit like that, say 10 years ago. Perhaps I looked at 3D printing maybe 10 years ago, and the whole issue was fraught with people trying to keep the things working, never mind actually printing something for any length of time. Can you imagine how demoralizing it was to send something to the printer that was going to take 2 hours to print, and after an hour and a quarter the thing would just keel over and die, and your print is totally ruined? These days, thank goodness, printers are now more plug and play. This printer that I got from Prusa, I had to assemble one little tiny bit of it. It took about an hour. And since then, it's been pretty much switch on, send it the file, it prints, job done. Okay, there's a few tweaks you can do on the actual printer itself, some very slight adjustments, but apart from that, it just works. So what is it I have to do to the printer to make it work? Well, I've got to feed in the filament, of course. Yeah, do I want this colour plastic or that colour plastic, or indeed that type of plastic? Because there's various different things you can print with, and for beginners I would say just start with the basics, called PLA. If you try anything else, you'll probably be very frustrated, annoyed, and eventually get fed up with it. PLA, though, I've not really had any issues with it. It sticks to the print bed nicely. The first layer sticks, and the print bed on this printer here, for example, is detachable. Here's one that I haven't cleaned off since the last time I used it, but this is one of the two print beds that come with that printer. This is the textured one, and well, apart from giving it this nice mottled finish to your prints, ensures that things come off because it's flexible, as you can see, like it bends. So when your print is done, you just flex it and the thing goes pop and off it comes most of the time. So it sticks to the print bed, and you can adjust just how much the first layer gets printed, but apart from that, it just, well, works, to be quite honest. What else is there to do? Well, on this particular printer, nothing. It's only got one nozzle. I can only accept one type of plastic and one colour plastic at a time. And I can see the advantages, of course, of having a printer that allows maybe 4 types of plastic and has 4 nozzles, each with a different type of plastic, and it understands which plastic is being used at which time on your design. So you can have either a multicolour design or indeed use different types of plastic, because some designs require you to give some sort of gentle support to the model as you're printing it, otherwise the whole thing will just keel over and flop onto the print bed. So you can actually have a different type of plastic holding things up until it's all finished, and then you take away that support plastic. You know, I know sometimes it's more difficult than just taking it away, but anyway. The actual printer itself is almost a non-decision these days. You can look at any of the modern printers and say, that looks great, it's got good reviews, I've read what the pros are, the cons are, and for a beginner I looked at the mini Prusa, and that cost me, I believe, in the region of €400, not pounds, euros. And I thought, as a maker, I'm only going to print small things. That's got a maximum print volume, width, depth and height of 180 millimeters, which is not huge. But then I think, well, how many huge things am I going to print? Now, some people out there do want huge things, yeah? Well, I can't do that, or at least I'd have to print them in chunks and then join them all together, which, funnily enough, that printer allows you to slice your actual print up, and then it'll automatically give you some lugs and things to join them all together. But I've not tried that, and it's unlikely that I'll ever get to that stage, frankly. I can't see myself wanting huge big prints, and if I do, well, maybe by then I'll be experienced enough to buy a bigger printer, but certainly not on the horizon at the moment. So that little baby printer over there is more than enough for my needs, and it was cheap enough for me to think I can go with that. It's got all the good reviews. It's self-leveling, so that print plate that I showed you, this one here, it's on a system underneath in it, and it sits there, and the electronics in the head has a look at the top and goes, yeah, where is this exactly? Because after all, let's face it, even 0.1 or 0.2 of a millimeter difference in height between this bit of the bed and that bit there is enough to cause your print to fail. So the electronics is clever enough to work out exactly how high and how warped that plate is, and it compensates for that. The auto bed leveling you'll hear a lot about, and as soon as I read that this one has cracked it, I thought, well, that's it then. They've matured to the point like cars, where you don't need a starter handle anymore. You don't need to know about the inside of the engine. You just stick the key in, turn it on, and it goes. Now, even if you carry on that analogy today and say, what do we have to do with cars to keep them going? The answer is not a lot. Okay, they get serviced once a year or thereabouts, but on a day-to-day basis, you go in, you stick the key in, turn it on, and drive off. But if that's all you did, you'd soon end up with problems, wouldn't you? Not least of which, after a while, one of the things on the dashboard is telling you you're running out of fuel. And if you took no notice, well, you'd come to a sudden stop somewhere, wouldn't you? And it could be quite inconvenient. So you still have to read the signs, read the dashboard, and of course there are other things on the dashboard that you might want to know about, like oil, for example, or if there's a warning light coming on, you need to know about it, look it up in the handbook and go, oh, that means this, I better get that fixed. Same with the 3D printer. There may be things coming up saying, oi, your filaments just run out. I'm pausing the print until you put some more in. Yeah. Or something's gone wrong. Sort it out. But so far, so good. But you do have to keep aware of it. It's not quite lock it up in a room somewhere and never touch it. That said, if you've ever seen the print farms at the Prusa factory, he has hundreds of Prusa printers all lined up, all printing more printers. You really should go to the website and have a look. I'll try and put a link down below so you can have a look. It's just mind-boggling. I'm sure there must be several people employed on a full-time basis going around replacing filaments and making sure that the printers are still operating okay. So, what have we learnt so far? So in summary, number one, it's the CAD program that makes the difference to you as a maker about what you want to make. And as I say, if you're not a maker in the sense that you want engineering type things to make, brackets, clips, cables, vents, enclosures, brackets to hold lights and things, whatever. If you're not after that, you're after more artistic modelling type things, then you need to choose your CAD program carefully that allows you to do that easily. Don't try and make an artistic model, for example, using free CAD. It's just not designed to do that. But similarly, don't try and use some artistic modelling CAD program to produce a complex enclosure with various bits and pieces. And that's where you need to spend the time and the effort getting it all running. And if you can produce models on your CAD program, well, you could at that point stop and say, do you know what, I'm not even going to buy a printer. I'm going to send this file to PCBWay now and they can produce it for me. Because after all, they got printers out there that can probably do 100 times more than what I can do here. So, and you can print in different plastics. Because, for example, I'd love to be able to print, say, in nylon. But nylon printing is, well, fraught with issue. I mean, it's for a start, it's not advisable to do it indoors because the fumes are given off. So you need it well ventilated, and well, I just haven't got the facilities for doing prints outdoors or having some kind of enclosure around my printer that's ventilated to the outdoors. So I think, well, if I wanted a complex print made of nylon, I'd send it off to PCBWay as an example. But as makers, if you think, well, PLA is good enough, or a push PETG, which is waterproof and a bit more stable outside and inside cars and things where it gets hot, that's fine. You can use any printer out there on the market today. Just beware that Prusa is up here, along with other companies like Bamboo, for example, high quality printers, and there are always going to be people who try to copy those and undercut the price. But how do they undercut the price other than by cutting corners? And then the next one comes along and tries to copy that copy and undercut the price again. And eventually it gets to the point where the thing is not reliable, not supported, and maybe the maker goes bust and you're left without any kind of support at all. So the actual printer selection is no more difficult really than choosing a car. If you choose some esoteric make from the Far East that may or may not be here tomorrow and has no track record of reliability, well, you can buy it, sure you can. Just be prepared to put in some effort and time in keeping the thing running. If you're going to buy a Volkswagen though, I think you can be pretty sure that Volkswagen will be here next year and the year after that and still enable you to get spare parts and things, and it will keep going forever, pretty much like this Prusa printer, I expect. Okay, Oh look, that print's nearly done. Oh, there it is. Which way is it? There, that print there, look. This is all backwards on my computer. Left is right, right is left. But that print there that's been chugging along, let me just show you that as an example of the sort of things that you can do and one day surprise yourself, as I surprise myself. I think, good Lord, I can actually make that now. And yeah, I'm actually providing value, not just for me and my maker environment, but for the household generally. So here's the cap that I've been printing throughout this video, and that fits on top of there. Bit cack-handed, doing it left-handed like this, but it fits like a glove. Absolutely wonderful. Now, it's only a spare. I just did it in case one of the others flew off in the wind, which one day no doubt it will. But there we are, all done. If you found this video useful, entertaining, edutaining at all, please leave a comment down below. Don't forget to give it a like, because I want to hear the hey! Yay, that's right. And I'll see you in the next video. I hope you're finding these videos useful and interesting. There are plenty more videos to choose, and a couple are shown below. And if you'd like to subscribe to this channel, just click on my picture below and enjoy the rest of the videos. Thanks for watching.